Thank you, Julian, for that very nice introduction. And thank you, everybody, for coming along to hear me tonight. My talk is going to be about innovation and projects. Now, both these words are part of most of our everyday vocabulary, but we probably don't think much about what they mean, and they probably mean different things to all of us. Innovation itself has been recognized as fundamental to the growth of economies and the long-term survival of businesses, and has therefore been viewed as important at the strategic level. In contrast, projects and their management have been tended to be consigned to the operational level. Now, I find this rather surprising, since most innovation and change in organizations is performed through projects. I'd like to see a future where projects are seen as important at the strategic level of organizations, so that more attention is paid to improving project performance. I'll return to these issues a bit later, but first I thought I'd say a little bit about why I'm so interested in projects and their management. And the simple fact is, projects have been a major part of my working life, both before and after I entered academia. So if we think about my earliest encounters with projects, it goes back to my childhood. It was in the big freeze in the winter of 1962-63. I know we've got a mixed audience here, but there are probably some of you who remember that. Does anybody remember that big freeze? Yeah, there's quite a few of you. It was quite interesting. If I remember it properly, it started snowing on Boxing Day. We were visiting our cousins down in Kent, and it kept on snowing into the next day, and it ended up more than a foot deep, which is pretty remarkable for the southeast of England. And then, of course, the temperatures plummeted. A layer of ice formed on top of the snow, thick enough to support my weight. I remember walking on the top of this ice without sinking into the snow. Usually, snow disappeared pretty quickly in the southeast. But that year, the freezing temperatures persisted right the way through until March. And it was only in March that the snow melted. So back to the project idea in this. I can't remember whose idea it was, but I think there'd been a TV program about Eskimos. And the next day, me and my brothers were sitting down there in the front row. We were playing in the garden. I think my dad was there as well. And we ended up building an igloo. I think it was my dad who organised the work. He was the project manager. We worked out the circumference of the base. We got a spade, cut the snow, because it was that deep, into blocks, like bricks, and steadily built up the layers on top of each other at a slight angle so that we could get the curvature. And we had to be careful to leave a hole in this for the entrance to the igloo. The hardest bit, of course, was getting the last few blocks in to make the roof without it falling in. Eventually it was finished. There was the plan, and there was what it looked a little bit more like. Not perfect, but it did the trick. After a few days, I remember getting up on top of it, and it was strong enough to take my weight on the roof. So we really had done a good job. And of course, we could all climb inside it and play at Eskimos, which was the aim of the project in the first place. So that was my first encounter with a project that I can remember. My first experience of a project from an academic point of view, though, was when I was an undergraduate at Sussex University. And part of my economics course there, I had to do a cost-benefit analysis of Brighton Marina. Like most big infrastructure projects, there were lots of stakeholders involved, many of whom had major differences of opinion on whether the project should go ahead or not. I seem to remember that based on the available information, and it was partial, my analysis came out in favour of them going ahead with it. Having said that, it was many years before the marina became profitable, and then only after following numerous changes of ownership and several major modifications to the original plans. After I left university, and this is a bit that Julian left out in my introduction. I worked for a number of years as a project worker in the construction industry. And I hasten to add that I wasn't a project manager. I was working at the ground level, so to speak. I was a ground worker. I dug holes. I did all kinds of things. And then I was a labourer. But I could earn more working as a labourer than I could as a newly qualified graduate in those days. And I needed the money. And it was just as well for me that the marina plans were approved, because I ended up working as a labourer on a sub-project at Brighton Marina, responsible for putting in all the marine installations, the floating bits. This is a picture of the marina as it was then, while it was being built. And down here, these are called pontoons. They're made out of a kind of concrete at the ends with a cement skim over polystyrene. And we had to, my job was basically joining these up together in long rows and then putting the, what were called fingers on, which is where the boat's more. So that's what I did. I worked there from 7 in the morning till 6 o'clock at night, 7 days a week. And I was able to save enough money for that to get a deposit on our first house. So it worked for me, the project. But I also learned a lot about working in teams, about interdependencies between different parts of projects. I also learned a bit about innovation too, because my workmate Tony and I made continuous improvements to how we did our work in order to maximize our bonus payments. And that was crucial, because our basic rates of pay was a miserable 85 pence an hour. I remember getting excited about the next job the company were planning as well. This was a major development. Sorry, that's more of those pontoons. The reason I want to pick this one up, actually, is because that's what used to be known as the inner basin at the marina. If you go down to the marina now, that's where all the houses are. So all that work I did putting all these pontoons out actually ended up being a bit of a waste of time. But I got my bonus and I got my house. So as far as I'm concerned, it was a success. This next project, and this was the slide I was looking for, the next project they were planning, my employers, was a major marina development in the Seychelles. Unfortunately, my dreams of working on a sun-soaked paradise never came true because the funding didn't come through, a familiar story for many project endeavours. So instead, when the marina project finished, I continued to work in the construction industry, but on projects that were much worse paid and with much less appeal. So they were working on renovating Georgian houses. That was quite nice, actually. It's nice to be able to do that. Perhaps a little less entertaining and a little less pleasant was working on retail developments in New Haven Town Centre, Arrow Tyres, a multi-storey car park for the supermarket that was done there. But I did learn a little bit more about how project work was going on. I remember one day, by which time I'd become what is known as an improver. That means you're a labourer, but you work on the tools, so you get paid a little more money as an improver. And I was doing form work, which is about how you make the infrastructure for pouring concrete onto it. It's plywood and other bits of wood and so on. And I'd noticed that the way the formwork had been designed meant that we'd have to throw it away when we came to strike the formwork. After the concrete was poured and it was cured, you take the wood away again and you're left with the concrete structure. I went to the foreman and I said, if we do it this way, we're going to have to throw it away. He said, I don't care really. There's a concrete lorry coming at 2 o'clock. Just go ahead with it. And that was the kind of attitude that prevailed at that time. They weren't really interested in changing anything. You did it by the book. You did it how it had always been done. And that was frustrating. I also was getting a bit fed up working long hours for low pay with no job security. So I was looking for other opportunities. And luckily enough, that was when I got my first break in academia. It seems amazing now that these kind of things can happen. But a friend of mine was working at the Science Policy Research Unit, SPRU, and he knew of a project where one of the researchers was going on maternity leave. they needed a replacement to carry out interviews with people in the engineering industry about technical change and how it affected skills and training. I remember being interviewed in a local pub by the project leader, who's also here tonight, Peter Senka. And I suppose my ability to talk to someone I'd never met before must have impressed him enough to give me a chance. And he gave me a 3-month contract, and so began my career as an academic contract researcher. So, Peter, it's all your fault. I'd like to thank you. And we'll have a drink later. So, by this time in my career, I'd given up working long hours for low pay and no job security in the construction industry in order to work long hours for low pay with no job security in academia. But on the upside, it was a lot warmer inside the office than it was on cold building sites in the winter. And it was also a lot more interesting. And as it happens, my temporary employment at Sprue lasted for 11 years. So I started on a 3-month contract, but I ended up being there for 11 years. I worked on more projects with Peter in the skills group, and these were for clients like the industrial training boards, remember those? Manpower Services Commission, who were interested in skills and training, the effects of new technology and so on. And then later, I moved on to work on projects about information and communication technology for the Economic and Social Research Council. So in particular, I looked at the structure and dynamics of software activities, and it was around this time that I also started my doctoral research on make or buy decisions on business software. But like all good things, it had to come to an end at some stage, and eventually my luck ran out. None of the proposals I'd put in a particular year got funded, and so I found myself out of work. God, it was brutal. But I'd learnt a lot as well. I'd had a total of 33 employment contracts during my 11 years at Sprue. This is the reality of being a contract researcher. But I'd also learned a lot about the business of projects. Things like how to turn an idea into a research proposal, how to satisfy different stakeholders, because one of the main aims was to keep the customer happy, so they give you repeat business. But you also had to publish. These were some of the reports we produced in the skills group, and out of that other work. And we also had to satisfy other internal requirements. So again, lots of different masters. I also learned how, once a proposal's been funded, you then had to deliver on the contract. So all the things you put in to secure the funding, what now might be called optimism bias, came back to bite you on the backside once the project started. I continued working as a contract researcher, this time at Bath University, where I was looking at strategic use of information systems. But then, in 1994, I got a call from Professor Howie Rush at Centrim, who said, we're starting a project here which is going to look at what we call complex products systems. It was funded by the EPSRC, and it was led by Howie Rush and Mike Hobday. So these were what I call the COPS years. Again, judging by the fact that a few of you can remember the big freeze, a few of you will know who that is. This is your friendly neighbourhood policeman, Dixon of Dock Green. And this is how we modelled ourselves in COPS. You know. People wanted to talk to us. You know. We were community-minded. We could get the information required without resorting to Sweeney tactics. But it also marked the start of a long and fruitful relationship with Andrew Davis, who's now Professor of Project Management at UCL, and also Paul Nightingale, who's a Professor at Sprue. And it was really in the COPS years that I started to learn about projects directly, because we were looking at innovation in these firms. And the fact is, production in these kind of complex capital goods is done in projects. It was another person I'd like to mention at this time is Peter Morris, Professor Peter Morris from UCL, because he just had a book out about project management, but he'd called it the management of projects. And this was crucial for us, just moving into this area, because it wasn't simply about a tools and techniques view of how projects are managed. It extended the view of projects, saying they were important at the strategic level and that not enough focus was placed on the front end and the back end of projects. Anyway, after this initial project at Centrum, we won further funding from the ESRC to establish the COPS Innovation Centre, and we sent this little postcard out to people as part of the launch for that centre. This provided us with core funding, which was fantastic for anyone who's been a contract researcher, because you're kind of underwritten. Your employment goes longer than your contract. And this, of course, enabled us to carry out some longitudinal research. So we got some real insight into the role of innovation and projects in these sectors. It was towards the end of the COPS Centre that I also became part of an interdisciplinary research network funded by the EPSRC called Rethinking Project Management. This network consisted of academics and practitioners interested in developing the field of project management and improving real-world practice. From that, I learned there was a huge difference between project management in theory and project management in practice. I continued my research interest on the management of complex projects, focusing on in-depth case studies. And again, as Julian mentioned, I looked at the Heathrow Terminal 5 project in collaboration with academics from Imperial College, including Andrew Davis. When I was in Finland, I looked at a Finnish oil company called Neste, who were making a very brave strategic move into the new and emerging market for biodiesel. And they went into a massive investment plan, putting 2 new plants in Finland itself and then 2 more, one in Singapore and one in Rotterdam, as they tried to become the world leader in the renewable diesel market. And that was with colleagues from Aalto University, but also Abo Academy in Finland. I also looked at various projects and programs related to the London 2012 Olympics, and that was with colleagues from Cranfield University. So again, what I learned from those kind of collaborative projects was that you could increase the output if you worked with other people in a sensible way. After that kind of run through my career to date, my relationship with projects, I'd like to return to the central focus of tonight's talk, which is the link between projects and innovation. And I suppose I ought to give you a few definitional things of what I mean by these. So the first kind of issue is, what is innovation? Now, a lot of people tend to think that innovation is invention, but actually that's not what it is. The word itself comes from the Latin word innovare, which means to make something new. So if it's not new, then it's not innovation. But there are differing degrees of novelty and varying types of novelty. It can be new to a single firm, new to a whole sector, or even new to the world. Innovation can also mean doing something better rather than doing something completely differently. But the key word, I think, here is make. Invention is about the idea. That may well be new, the idea, but innovation is not merely the idea. As John Besson and Joe Tidd point out in their textbook on this, innovation is really a process, the process of turning new ideas into reality and gaining value from them. I haven't got time, because this is quite a short lecture tonight, to go into much detail, but I'll just briefly point to some different kinds of innovation as well. There's product innovation, the iPhone, for example. There's service innovation, something like internet banking. There's also process innovation, so there we could think about the use of robots in factories. And more recently, business model innovation has been added to this list, where the whole way firms make money, deliver products and services has changed. So think there about budget airlines or Amazon as examples of this kind of innovation. When something's an improved version of an existing product or service or process, we call that incremental innovation. These kind of innovation don't really require any new knowledge or any new capability. But radical innovation, on the other hand, results in major changes in the order of things, which may render existing capabilities obsolete and knowledge redundant. Digital cameras are a good example of this, something that's disrupted the whole photography sector. So those are different kinds of innovation, but how does innovation actually take place? And that's where projects come in. New ideas are turned into innovation through projects. So what do I mean by a project? Well, although projects must have been used for major construction and civil engineering endeavours in the past, we've got examples like the pyramids, Great Wall of China, Roman amphitheatres or great Byzantine churches. It's only since the mid-20th century, really, that they've emerged as a significant form of industrial organisation. It was in the 1940s and 50s, really, when the most notable projects were the weapons systems development projects, such as the Manhattan Project to develop the atomic bomb, and the Atlas on the left and the Polaris missile projects. I'll come back to those later. I'd just like to say project forms of organisation were also used extensively in construction and civil engineering, and through the 1960s and 1970s, they spread to other sectors, including engineering, power generation, petrochemicals, pharmaceuticals, computers and information systems, telecoms, research and consultancy. They were really widespread. So what exactly are projects? According to a well-known textbook, a project is a combination of human and non-human resources pulled together into a temporary organisation to achieve a specific purpose. So, people are involved, technology is involved, non-human resources. It's temporary, it has a start and it has a finish, and you have a specific purpose that you're trying to achieve with this. That's when you know, or you hope you've achieved that in the end when your project is over. This is a formal description of what's supposed to be happening in a project, but I think it misses something about the essential part of a project. That is about creating a change from an existing state. If we go back to the roots of the word, the Latin word projectio, projectum, it's made up from pro, from a place, and iaceo, to throw. So really, when we talk about a project, it's about throwing something forward. That's where the word projectile comes in. Throw a projectile forward. So projects are really about throwing something forward, getting an idea that's thrown forward from an existing position to a future world. So projects really are the vehicle for a whole range of tasks related to innovation. For example, achieving organizational change, development of new products and services, process improvement, implementation of IT and production technologies, mergers and acquisitions. All of these are examples of where you change from one state to another state through the project. One of the main reasons for this talk is that projects remain poorly understood and are bedeviled by poor performance. So on the one hand, we see they're really important. They do all this innovation stuff, but they're bedeviled by poor performance. And this is across a range of sectors, including IT and software projects, transport projects, and this was the construction project to build Wembley Stadium, which we're still paying for because we had American football teams playing on the surface, so the pitch is all churned up so that they can maximise their returns to pay for the doubling of the price. And there's also aerospace projects in the defence. This was the Nimrod debacle, which cost taxpayers £3.4 billion. It's on that note that I'd like to introduce something rather out of left field. The bit of left field I'm talking about is this. I want to introduce science fiction into the talk. And there are a couple of reasons for that. One of them is that science fiction is often thought as a predictor of future innovation. And we only have to go back to last week and the remarkable news about that space probe landing on a comet after a 10-year journey to think about that. That would have been pure science fiction, even in the end of the last century. But they've done it. So what really is science fiction? And my colleagues here will have no surprise now to hear me turn to my favourite science fiction author, Philip K. Dick, to try and find out about that. Now, some of you may have heard of Philip K. Dick. He's probably best known now because of all the films that have been made about his novels and his short stories, such as Blade Runner or Minority Report, Total Recall. And he said, science fiction is about a society that doesn't in fact exist, but is predicated on our known society. That is, our known society acts as a jumping off point for it. So, science fiction involves that which general opinion regards as possible under the right circumstances. So it has to be something that actually there's a grain of truth in. We could see these kind of things happening. And in that respect, science fiction is a little bit like a project. It involves throwing forward from an existing point. But the idea also has to be feasible. Dick also makes an interesting distinction between science fiction and fantasy. Fantasy involves that which general opinion regards as impossible. Having spent so much of my adult and working life either working in projects or studying projects, I've come to the conclusion that the traditional view of project management when it comes to complex projects is nothing more than a fantasy. So what do I mean by that? The fantasy of project management is this. Project management textbooks, professional bodies of knowledge, suggest that once the client has handed over their well-defined problem, then projects simply manifest a means-end reasoning through a stage process from project initiation to planning and design, then execution, and finally completion. And if that was the case, then why do so many projects fail? I think the reality of project management practice is rather different. In the real world, project management means dealing with a rather messy situation that becomes increasingly messy as projects become larger, more software and IT intensive, and more political. In the real world, projects don't run smoothly from start to finish. I learned a lot about that doing research projects all those years. Project management requires judgment and experience to cope with conflicting stakeholders' aims and objectives, to act effectively in the face of a constant stream of problems, some of them predictable, but others less predictable. So it's my contention that it's adhering to this fantasy that explains why so many projects are seen to fail. They're complex. According to some eminent researchers in this field, Shenhar and DeVere, projects exhibit high failure rates because senior managers and project teams underestimate up front the extent of uncertainty and complexity involved in their projects and fail to adapt their management style to the situation. These guys have researched hundreds and hundreds of projects, and they've come to this conclusion. But rather dwell on project failure, I'd like now to shift the focus of the talk towards project success. There's been recent research which has re-examined the early days of project management, where there were some notable successes, and suggests that we might usefully go back in time to see how they dealt with complexity and uncertainty in those projects. So, if you'll suspend belief for a moment, I'd like you all to step into the DeLorean, buckle up, accelerate the car to 88 miles an hour to activate the flux capacitor, and join me in a trip back to the 1950s to see what we can learn. So, be ready. These weapon systems projects I spoke about earlier took place in an environment of complex technical change and huge uncertainty. There were many new technologies around, such as radar, nuclear fission, rocket propulsion, electronic control, that had been developed during and after the Second World War. There'd also been an escalation in the number of components and parts in the systems being developed. For example, in the aeroplane gas turbine engines, the number of parts had more than doubled from 9,000 in 1946 to over 20,000 by 1957. And a further complexity related to the interdependencies between parts of the system, which meant that changes to the aircraft, for example, affected the armament that you could put on them, and vice versa. And there was also the idea that all weapon systems components had to be developed from the start. The airframe, the electronics, the armament, the logistics, prior to their integration. Now, to deal with their increasing complexity, engineers created systems engineering, and managers created project management. And these were innovations at their time. They hadn't really done these kind of things before. Systems engineering involved the design and development of systems, and the emphasis there in systems engineering was on meeting technical specifications. Engineers, physicists, rocket scientists worked together in multidisciplinary teams to design these systems. Project management, on the other hand, required the development of new tools and techniques and new organizations to manage the system development with these multidisciplinary teams and also to deal with the external stakeholders. On the management side, the emphasis was on meeting cost and schedule constraints rather than the technical side of it. Now, based on a study of more than 50 development projects by economists at the RAND Corporation, a really important institution at the time, two schools of thought emerged about how you could go about best to develop these complex projects under conditions of uncertainty. And these were characterized by Mr. Optimizer and Mr. Skeptic. The reference there is about a paper that was written in the 1950s based on this, but it kind of disappeared. It's never really been picked up by project management scholars until more recently. Now, Mr. Optimizer, he systematically analyzes and compares all the alternatives that the final systems might look like, those that are considered promising in any case. Then he makes estimates about the performance of all the subsystems and components, what they might achieve by the target date. He tries to match these alternatives to a detailed model of the future operating environment. And then, according to some kind of criteria for choosing the most efficient system among all these alternatives, he chooses which end product is best, chooses one of those. Now, Mr. Skeptic, on the other hand, refuses to define what is optimal at an early stage because there's too much uncertainty. Instead, he contracts for several prototypes to be developed in this early stage, which will yield information about their suitability. So there's an element of learning there. When you don't know which one's going to be right, you try out several. He maintains flexibility by committing resources to the project in stages, constantly reviewing the state of knowledge before moving on. This also enables learning to take place, which allows better decision-making at later stages. Now, that study that I talked about found that if Mr. Optimizer's assumptions are right, this guess about the performance of the single choice, then certainly that solution will be the most efficient. But if they turn out wrong, this is the worst effect you can have, because there are serious consequences both in terms of the quality, in terms of the cost, in terms of schedule overruns. So their conclusion was that Mr. Skeptic's strategy is often the most efficient. And it so happens that the Manhattan Project, the Atlas and Polaris projects, were examples of project management success that had used parallel trials, concurrent engineering, flexible trial and error approaches, much as Mr. Skeptic would have recommended. But all this was to change in the 1960s. The focus gradually changed from performance at all costs, and certainly these weapon system development projects were very well funded. The focus changed from performance at all costs to one of optimizing the cost-performance ratio. This coincided with Robert McNamara, who'd been running Ford, becoming Secretary of Defense. And the phased planning approach became the mandated project management model for the DoD and the newly formed NASA. But as project management practices spread to other domains beyond military and aerospace, this approach became a de facto standard, and many complex projects suffered problems of overruns and cost and failure to deliver planned outcomes, as captured by this wonderful cartoon by Gary Larson. If you can't read that bit at the bottom, it says, "It's time we faced reality, my friends. We're not exactly rocket scientists." So, having absorbed how complexity and uncertainty were successfully managed back in the old days, it's time to leap aboard the DeLorean again and travel back to the future, this time to the recent past. Having taken this trip back to the early 20th century, it's a bit depressing to find out that the failures that I put up earlier of the early 21st century aren't that different from the failures at the end of the 20th century. We might have expected some kind of innovation to have taken place in terms of project management so that performance was improved. Instead, it's as if there's been no learning for 40 years. And according to this young gentleman, Albert Einstein, doing the same thing and expecting different results is madness. But luckily, as we've entered the 21st century, there have been a few signs of improvement in project performance. In sharp contrast to numerous mega construction projects, the Heathrow Terminal 5 project was delivered on time and to budget. BAA, the client, adopted an innovative approach based on learning both from its own prior projects and from other sectors. They undertook detailed studies of large construction projects, which had been undertaken in the previous 10 years, and also all airport openings from the previous 15 years. Their findings suggested that if they adopted a traditional approach to these projects, it would be 2 years late, cost £1 billion more than they could afford, and result in a number of fatalities. And none of this was acceptable to them. So they created a new approach based on the client bearing all the risk and working in integrated collaborative teams. They also developed an innovative approach to contracting called the T5 Agreement, which laid down a set of behaviours which BAA and their first-tier suppliers signed up for, based on trust and cooperation, in contrast to the usual confrontational approach that was typical in construction projects. Prior to its opening, T5 was being heralded by the press as a breakthrough in project management. History in the making. Unfortunately, this came back to haunt them when disaster struck on the opening day. Heathrow shambles as T5 opens, desks closed, flights cancelled, luggage piling up. Not very happy passengers. What happened then was there were a number of minor problems which conspired together to create a total systems breakdown. We've written something about this elsewhere, and I'm not going to go into details there. But the point is that all the good headlines from the year before were destroyed through that mistake in their opening. Making history, it's memorable, but for all the wrong reasons. And if you go around, talk about this now, and ask people whether T5 was a success or a failure, a lot of them remember this rather than a successful construction project. So, one encouraging postscript to this little story is that BAA continued to learn after T5, as demonstrated recently by the rather low-key opening of the revamped Terminal 2. I don't know if any of you even knew that it had been opened yet. They learnt from the disaster of T5, and instead of going for a big bang approach, or a damp squid approach, as it turned out, instead they went for a phased build-up over a 6-month period. So to full capacity. The move from the construction phase of the project to the operational phase was given a huge amount of attention in their approach to the project because of their failure before. So they learnt from their failure instead of just making the same mistakes and repeating the errors of the past. So that's quite encouraging. And T5 isn't the only UK project success story. The London 2012 Olympics has further restored our faith in our ability to manage large and complex projects. And similar good practice is found in the Crossrail project. And only last week I was a speaker up at a workshop for project and programme managers up in the north of England from Scottish and Southern Electricity. And one of the other speakers on the day was the guy who's in charge of integrating all the different parts of the aircraft carrier and integrating them together as a single aircraft carrier. That's them trying to put the aircraft carrier together. Once again, a collaborative, flexible, Mr. Skeptic type approach is being used, even in this project, to cope with the uncertainty associated with the complexity of the project. So, putting all these recent examples of success together, we can suggest a new model of project management for complex, uncertain projects, which is a sort of hybrid somewhere between Mr. Skeptic and Mr. Optimizer, which tries to take the best of both worlds. My colleague Andrew Davis refers to this as a tight, loose approach. So, what does this mean? Firstly, you need a strong client leadership and involvement. Secondly, you need strong governance. So you need a good assurance system, strong upward reporting from in the project. You need collaborative working in integrated teams so that you're all working together towards the same outcome. But you also have to have flexibility, this ability to have different contracting approaches in sub-projects according to the situation. So within a large program, there may be some elements that aren't uncertain, that are highly predictable. You don't need the same contracting conditions for those kind of projects as you do for the more uncertain parts of the project. You also need adaptability, because these projects take a long time and things are bound to change, whether it's the external environment that they're going to operate in, whether it's the funding environment, or whether new technologies come along. So you have to be able to respond to changes and to change your plans. And finally, you need to do learning along the way during this. Look outside your project. See if there are other approaches elsewhere that can help you. So, let us take a final trip in the DeLorean, this time to my vision of the future. Those examples of better performance and encouraging signs we've been seeing are happening just as we're entering a major phase of investment in new infrastructure over the next 10 years or so. In December 2012, the government announced it was going to be spending some £310 billion on infrastructure projects, mostly on energy and transport, but also on water and waste and telecommunications. I'm currently a member of ICIF, the International Centre for Infrastructure Futures, a consortium of UK universities, UCL, Southampton, Bristol, Cranfield, Sussex and Brighton. And we're conducting multidisciplinary research, which takes a systems thinking approach to infrastructure research with a focus on new business model design. We're going to try and see if people can be creative, come up with an idea, start with a blank sheet of paper, and how would you do this if you didn't have the legacy systems of the past? I'm hopeful that recent examples of good practice and learning will continue to be built on, and that we'll see further innovations in project management. But innovation is a risky and political business. And so I'm going to finish tonight with a few words of caution from someone who knew a thing or two about this, Machiavelli. He said about innovation, "It ought to be remembered that there's nothing more difficult to take in hand, more perilous to conduct, or more uncertain in its success than to take the lead in the introduction of a new order of things. Because the innovator has for enemies all those who've done well under the old conditions, and lukewarm defenders among those who may do well under the new." So, thank you everybody for listening. I hope you enjoyed it. Thank you.